Okay, and welcome to 2.6 day 2. Again, we've got a couple of theorems to go over, so let's go over them really quickly. So, 2.6 again is angle relationships. Theorem 2.8 says that vertical angles are congruent. So remember, vertical angles look like this, made with two straight lines. The vertical angles that are congruent would be those two, or those two. Vertical angles are these ones. Right there. And they are congruent. Always. Always, always, always. Theorem 2.9 says that if two lines are perpendicular, then they form right angles. So perpendicular lines look like the little symbol, which is an upside down T. They make right angles. That's just by definition of perpendicular lines. But we also have a theorem for it just so we can just skip ahead to that step. So, those are the first two theorems. Next couple, theorem 2.10. Again, these numbers kind of like overlap with the last ones, so just kind of move on forward. So, all right angles are congruent. That is true. All right angles are 90. And if they're all 90, then they're all congruent. The next one says, if two lines are perpendicular, then they form congruent adjacent angles. If I were to draw an example of this that would actually look like a 90, like this, then I would have made two right angles. I would have made one right here and one here. And remember, adjacent means next to. So I have two angles right next to each other that are congruent because they're both 90. And all right angles are congruent. So, perpendicular lines form two congruent adjacent angles. Next one, if two angles are supplementary and congruent, then they are right angles. These two angles right here, I'll use the same picture. These are supplementary. They make a straight line like this. But not like that. But you get the point. They make a straight line. And they're both 90, which means they're both congruent. Then they are also right angles, because they are. Same picture. This all will relate to the same picture. And then lastly, if two congruent angles form a linear pair, then they are right angles. Again, these are a linear pair. They make a straight line, so they are right angles. And they're congruent, so they're right angles. So again, these all kind of relate together. Next. We got some proofs in here. These ones are pre-written, so I'm just going to kind of go fast through this. So this one, our given is angle 1 is congruent to angle 3. So if I were to draw a picture of that, ooh, angle 1 is congruent to angle 3. So I've got my given written down, and that was given. The next step I would want to do is say, well, angle 2 and 3 are vertical angles, so I know that vertical angles are congruent. So angle 2 is congruent to angle 3 as well, because they're vertical angles. Vertical angles are congruent. And then lastly, we've got angle 1 is congruent to angle 2 because of the transitive property. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3, so angle 1 is congruent to angle 2. Great. Next one. On this one, we are told that, let me get my marker, that angle, or the NO, line NO, this one, is perpendicular to OR. So OR is this bottom line, and NO is this vertical line, and they make a right angle. They are perpendicular. We're also told that POR, this angle, is complementary to PRO, which is this angle. If I could draw PRO. And we're trying to say that NOP, this one, is congruent to PRO, that one. So let's first start by writing down our givens. So, NO is perpendicular to OR, and POR is complementary to PRO, given. The next thing that we want to say, well, NOR is a right angle. That's true, because perpendicular lines make right angles. Definition of perpendicular. So NOP is complementary to POR. If both of these angles make up this right angle, because we know that NOR is a right angle. I'm going to erase some of this so I can draw better. We know that NOP and POR make up this right angle, so they are complementary. If two angles form a right angle, then they are complementary. I know you can kind of not see it behind there, but that's what it says. If two angles form a right angle, then they are complementary. Okay, and the last step. PRO is congruent to NOP because if two angles are complementary to the same angle, then they are congruent. So we know in this step that POR is complementary to PRO. So POR, this angle, is complementary to PRO, this one. And we know that NOP is complementary to POR, which is this one, because they form a right angle. Therefore, since they're both complementary to the same angle, then they are congruent. So if two angles are complementary to the same angle, then they are congruent. That is one of the properties that we learned in the day one part of these notes. Great, cool. Next one. Angle B is this one, and it's congruent to YRX. YRX is this angle right here. We're also told that angle Y is congruent to TRB, which is this one. I'm going to mark those with 2 lines. And we need to prove that angle B is congruent to angle Y. So let's start by putting down our givens. Our next step is saying, well, TRV is congruent to YRX, and I'll show you in a second. TRV is this angle, and it's congruent to YRX because they are vertical angles. Vertical angles are congruent to each other. Therefore, they are congruent. And Y is congruent to YRX. So angle Y is congruent to YRX. Angle Y, YRX are congruent. I'm just going to keep marking these in different colors because of the transitive property. Y is congruent to TRV. TRV is congruent to YRX. So Y is congruent to YRX. Therefore, angle Y is congruent to angle V, again, by the transitive property. Angle V is congruent to YRX. YRX is congruent to Y, therefore Y is congruent to V. And we're done. Easy peasy. Last one. Let me draw some pictures. Let me get a blue. I like blue, or no, orange. Angle 2 is congruent to angle 1. That's our first given. Our angle 1 is congruent to angle 2. And angle 1 is congruent to angle 3. And we're trying to say that FH, this line, bisects angle EFG, which is this big angle here. So, again, first things first, let's write down our givens. Our givens are that angle 1 is congruent to angle 2, and that angle 1 is congruent to angle 3. Given. Next is saying angle 2 is congruent to angle 3 by the transitive property. If they're both congruent to angle 1, then they are congruent to each other. Next up, that line segment FH bisects angle EFG. And that's the definition of an angle bisector. If two angles make up a whole angle, which they do, EFG, and they're congruent, then angle FH is a bisector. Because a bisector cuts an angle into 2 equal parts. Done. Easy. Done. Okay. Take a look at the homework for the section, and then come to class prepared to ask some questions so we can go over some stuff. Yay! Okay, I'll see you guys soon. Bye!